MS Ramaya University of Applied Sciences.
Hi students, let us discuss Morse test, multi-cylinder petrol engine. Significance. What is the need in doing Morse test? To evaluate performance of each individual cylinder, to calibrate and draw performance maps, to program engine control units. Multi-cylinder petrol engine is used for automotive applications. Power is defined as the rate of work done and is equal to the product of force and linear velocity or the product of torque and angular velocity. Power developed by an engine and measured at the output shaft is called the brake power BP. Measurement of power involves the measurement of force or torque as well as speed. The force or torque is measured with the help of a dynamometer and the speed by a tachometer. Power P is equal to 2 pi Nt by 60 into 1000 kilowatt, where T is torque in Newton meter and N is engine speed in revolutions per minute. Indicated power. Power developed in the cylinder and thus forms the basis of evaluation of combustion efficiency or the heat release in the cylinder. Difference between the indicated power IP and brake power BP is the indication of the power lost in the mechanical components of the engine. Loss in the form of friction and other forms, which is mechanical efficiency. Mechanical efficiency is equal to BP by IP. Difference between IP and BP is called friction power FP. Brake power is equal to 2 pi Nt by 60 into 1000 kilowatt, FP equal to IP minus BP, IP engine equal to IP cylinder 1 plus IP cylinder 2 plus IP cylinder 3 plus IP cylinder 4. FP engine is equal to FP cylinder 1 plus FP cylinder 2 plus FP cylinder 3 plus FP cylinder 4. The block diagram shown represents simple layout of multi-cylinder SI engine test rig. Measurement techniques. Fuel flow measurement. Measuring volume flow and then correcting it for specific gravity variations is quite inconvenient and inherently limited in accuracy. Instead, if the weight of the fuel consumed is directly measured, a great improvement in accuracy and cost can be obtained. Engine speed measurement. Accurate and continuous measurement of speed, a magnetic pickup placed near a toothed wheel coupled to the engine shaft can be used. Magnetic pickup will produce a pulse for every revolution and a pulse counter will accurately measure the speed in revolutions per minute, that is RPM. Torque measurement. As shown in the figure, it consists of a stator on which are fitted some electromagnets and a rotor disc made up of copper or steel and coupled to the output shaft of the engine. When the rotor rotates, eddy currents are produced in the stator due to the magnetic flux set up by the passage of field current in the electromagnets. These eddy currents are dissipated in producing heat so that this type of dynamometer requires some cooling arrangement. Torque is measured with the help of a moment arm. Load in internal combustion engine testing is controlled by regulating the current in the electromagnets. With this brief introduction on Morse test, multi-cylinder petrol engine, we will start the experiment.
Hi, let me show you how to conduct the Morse test experiment. Now let me explain you the various components of the 4-cylinder petrol engine. So first component of this equipment is the control panel, then 4-cylinder water cooled petrol engine. This is the 4-cylinder water cooled petrol engine. This is connected via shaft to the eddy current dynamometer. Then we are having the fuel tank, and then we are having the airbox. This is the water cooled engine. The engine is cooled by the water. The water line is connected to the here like this way. You can see here to the main water supply here. Also the eddy current dynamometer here. This is also a water cooled eddy current dynamometer. This is also connected to the water supply line here. And whatever the exhaust gases are coming out of the engine, this is passed to the exhaust gas calorimeter here. For this also we have to supply the water here. So for that purpose there is a water line here. Various sensors used in this experiments are, first one is the RPM sensor, second one is the load cell to measure the torque applied to the engine. This sensor is used to measure the water flow quantity to the engine, and this sensor is used to measure the water flow quantity to the exhaust calorimeter. Now we will see on the temperature probes. This is the thermocouple which is used to measure the water inlet temperature to the engine, and this is the thermocouple which is used to measure the water outlet temperature from the engine. These two are connected to the engine. This is the thermocouple which is used to measure the air inlet temperature to the engine. Then this is the thermocouple which is used to measure the exhaust gas temperature from the engine. Then this is the thermocouple which is used to measure the exhaust gas temperature from the calorimeter, and this is the thermocouple which is used to measure the water outlet temperature from the calorimeter. Air pressure is measured using the manometer that is connected to the control panel. Okay, and the fuel supply to the engine is measured using the load cell which is connected at the bottom of the fuel tank. Engine control panel consists of engine on indicator, then oil level indicator, then cylinder cutoff switches, then ignition on key, then accelerator knob, then we are having the clutch to connect and disconnect between the engine and the dynamometer. All the sensors from the engine are connected to the display unit here. In this unit it consists of torque indicator, speed indicator, then multi-channel temperature indicator, then high temperature indicator which is going to measure the exhaust gas temperature, then fuel rate indicator, then flow rate indicator from to the engine, then we are having the air consumptions indicator, then we are having the one more flow rate indicator which will measure for the calorimeter, then we are having the loading switch, and we are having the load controller. To conduct the experiments you have to follow the procedure like this way. First, switch on the display unit. Supply to the eddy current dynamometer has to be switched on here. Then water supply to the engine has to be supplied here. The water is flowing in the channels here. Now the flow rate to the engine has to be set to around 160 cc per second, and to the calorimeter has to be set around 40 cc per second. Let us start the experiment. Switch on the engine. Engage the dynamometer to the engine. Then give the 3 rotation to the accelerator. 1, 2, 3. Then apply the loading switch. Then set the torque to 10 Newton meter by adjusting the load control. Now you note down the engine RPM here. In this case, it is showing around 2700 RPM. Now to conduct the Morse test, you have to follow the procedure like this way. Now what you have to do, first cut off the one of the cylinder here. After cutting off the cylinder, now come back to your control unit here. Now you have to check the RPM of the engine here. In this case, the RPM of the engine is reduced to 2400 RPM. So now we have to adjust the load to increase the RPM to 2700. So for that purpose, now I am going to reduce the load here. Now note down all the reading available from the display unit. To continue the experiment, to determine the performance of the second cylinder, first you have to enable the first cylinder, then wait for few seconds, then cut off the second cylinder here. Now once again check back here in the control panel. Now in this case, now the RPM of the engine is increased. So for that purpose, now you have to increase the load here to reduce the RPM of the engine. Similar way, conduct the experiments for two more cylinders to determine the performance of that cylinder. This completes the Morse test experiment. Now to shut down the engine, follow the procedure like this way. First, reduce the load. Then switch off the loading switch here. Then reduce the accelerator by rotating the knob back to idle position. Then disengage the dynamometer from the engine. Then switch off the ignition key. This shut off the engine.
Readings from test rig and performance outputs is as shown. This completes the experiment. Thank you.
At MSR UAS, we spark your imagination unlike any other.